Hey everybody, we're going to continue with the 2018 MCAS today. We're starting session 2, which is the calculator session. So you can use the calculator, and also don't forget you have access to the formula sheet, which is in the back, towards the back of this. Also, you should have already tried this before you watch the video. There's a PDF that's in the video description, so you can download it, print it up, and try it. And then, the purpose is to explain the problems. All right, so let's get started. Number 22, Rasha and Scott went to a bakery. Rasha bought 4 plain bagels and 2 chocolate donuts for a total of $8.70. Scott bought 3 chocolate donuts for a total of $2.55. What is the cost of 1 plain bagel at the bakery? Okay, so let's see the best way to figure this out. So we need to figure out how much the chocolate donuts are first. If we're trying to figure out the cost of plain bagel, it's part of a 2-variable equation up here, but we can solve for the other variable by itself because it says 3 chocolate donuts cost $2.55. So if we divide $2.55 by 3, we should get the price for a single chocolate donut. So let's do that. So make sure you can see this. So $2.55 divided by 3, that'll give us the cost of a single chocolate donut. So you can see this. So $2.55 divided by 3, it's 85 cents. Now that's not the answer to the question. That's how much the chocolate donut costs. So this is chocolate donut. So Rasha bought 4 plain bagels. We're going to 4p. P will be the variable we're solving for. And 2 chocolate donuts plus 2 times whatever this is, 85 cents. And that would equal $8.70. So now we can solve for p, the price of a single plain bagel. All right, so let's multiply the 2 and 85 cents. So 85 times 2, and that should be $1.70. So 4p plus $1.70 equals $8.70. And subtract 170 from both sides. So 4p equals $7. I'll divide by 4. It's our coefficient. So $7 divided by 4 equals $1.75. So P equals 175. Okay, and that would be C. Okay, the first term of an arithmetic sequence is 5. The third term of the sequence is 13. Which of the following expressions represents the nth term of the sequence? Okay, so this is an arithmetic sequence problem. So the first term, so a sub 1 equals 5. We don't know what a sub 2 is. Okay, a sub 3 is 15. Okay. Which of the following represents the nth term? Okay, so we need to find the common difference to solve this. So it's either going up by 4 or 5. Now, if you look from 5 to, I'm going to put 15 there. It should be 13. That's weird. It should be 13. So to go from 5 to 13, I went up by 8. Right? Now we know that each of these would be an equal increase, right? An equal increment. So if you divide 8 by 2, you're going to get 4, which makes sense because it would have to go up by 4 here and 4 here. So the second term in the sequence, not that we really need at this point, would be 9. It would be 5, 9, 13. All right, so our common difference is 4. So D equals 4. And I'm going to lock the screen here. My a sub 1 is 5. Okay. So let's go ahead and look at the arithmetic sequence formula. It's going to be a sub 1 plus n minus 1 times d. So a sub 1 is going to be 5 plus n minus 1 times 4. And distribute this. So this is a sequence. This arithmetic sequence has been prevalent in the last 2 MCASs since it went to digital format. So it would not shock me if they expect you to know this formula again. And this is not given to you. This formula right here is not given to you in the formula sheet. So we're going to combine 5 and negative 4. So 4n plus 1. That should be option A. Okay. take a look at number 24. Just a little bit here. All right, quadrilateral RSTU is graphed on the coordinate grid below. Quadrilateral RSTU will be reflected over the y-axis and translated 4 units down. What will the coordinates of the image of point S? What will be the coordinates of the image of point S after the transformations? Okay, so this is a composite or series or sequence of transformations. We're looking at a reflection followed by a translation. So they want to know the coordinates of S. So let's look at S. We're going to deal with just S. So S is going to be reflected over the y-axis. So here's the y-axis. Right. So if you forget the rule, no big deal. I mean, you're going to basically, for the rule, you just take the x value and change its. Sorry, I totally screwed it up. I am out of it today. I apologize, guys. A bit of a cold. The y-axis is right here. What am I doing? So that's the y-axis. That's why I don't do these in pen, right? So we're going to reflect it over the y-axis, which means we're going to change the x value. Okay, so 5 will become -5. You can also tell just by counting the distance from the line of reflection, which is 1, 2, 3, 4, 5. So we're going to go 5 the other way. 1, 2, 3, 4, 5. So that's S prime. But now we need to translate it 4 units down. So we're going to go 4 down. 4 spaces down. So 1, 2, 3, 4. That'd be S double prime. And that's the point we're looking for. So it'd be -5, -2, which is right here. Now, if you weren't sure, what you could do is actually graph all these points and see when fills the needs. But as long as you don't have a brain fart like I did and know where the y-axis is, you should be good. Okay, let's move along. That was a previous question. Let's see here. Let's see. Okay. So 25. Box Whisker Plot. Okay, we can do that. Says the Box Whisker Plot below shows the distribution of numbers of calories per serving for a selection of breakfast cereals. So here it is right here. Let's zoom in a little more so you can see a little better. Based on the Box Whisker Plot, what is the median number of calories per serving? So median is going to be the Q2, which is right here. So that's our Q2, which is 125. It's never going to be that simple on the new MCAS. It's never going to be like, hey, identify the Q2, here's the Box Whisker Plot, or here's the median, here's the Box Whisker Plot, show us where it is. It's just not going to be that easy now. You're looking at, you need to know that, but it's not going to be as simple. So if you've watched the previous videos with the current digital format, you'll know what I'm talking about. Okay, number 26. The diagram below shows a cup in the shape of a right circular cone and some of its measurements. Which of the following is closest to the volume in cubic centimeters of the cup? Okay. So we have the height and we have the radius, which is what we need to calculate the volume of a cone. And again, this is in the formula sheet, which is attached. It's part of this test, actually. It's part of the, it's like the second to last page near the answer key. So we're looking for the volume closest to the volume because this is an estimation. This is not an exact answer. We know that because there's no pi symbol here. So let's go ahead and write the formula, which is V equals 1/3 pi r squared h. So it's very similar to the cylinder formula. You just have the 1/3 in front of it. Okay, so let's go ahead and plug these in. So V equals 1/3, and we're going to go ahead and do 3.14 because we know we're going to estimate it. R is going to be 5, so 5 squared. And I should put that there, actually. And then IH is 10. Okay, so let's do 5 squared first. It's going to be 25. So 1/3, 1/4, 25 times 10. I'm going to multiply the 25 and the 10, because order doesn't matter when you're multiplying, because it's commutative. 1/3 times 3.14 times 250. And we'll do the rest on the calculator. We're going to multiply these and divide by 3. So we have 250 times 3.14. That's 785. divide that by 3 because it's the same as multiplying by a third. And you get 261 2/3. And that's going to be centimeters cubed. Okay, so which of these is closest to it? I would say option C, 262. Okay. So let's see, number 27. The volume of a right circular cylinder is 1,696 cubic centimeters. The height of the cylinder is 15 centimeters. Which of the following is closest to the radius of the right circular cylinder? So we're going to be solving for one of the dimensions of this shape. This is not that uncommon. So we're given a right circular cylinder. That's the shape. We're given the volume. We're given the height. We're looking for the radius. Okay, so let's write the formula. So V equals pi r squared h. And again, it's closest to, so we're going to be plugging in 3.14 for pi. The volume is 1696 or 1,696. Pi is going to be estimated as 3.14. We're solving for r, and h is 15. Okay. All right, so let's multiply these together. So 15 and 3.14. So 15 times 3.14, and that equals 15.7. So we're going to have 1,696 equals 15.7 r squared. And we're going to go ahead and divide by our coefficient. So 1696 divided by 15.7. So we get 108.0. That doesn't look right to me. Okay. 108. I'll just keep it around 100.8. It's r squared. And then we're going to square root both sides to get r. So it's going to be wait, something screwy happened here. Hold on a second. Okay, I found my mistake. I must have made an error typing the numbers in here. If I go back and watch, I'm sure I can see it. But the major issue here is when I multiplied 15 by 3.14, I somehow thought it was 15.7, which is obviously not what it is. I apologize, guys. I got a bit of a cold I woke up with this morning, so it's definitely affecting me here. All right, so let's go ahead and try it again. So 15 times 3.14. So I crossed that out. You're not sure. I knew something was up there. 3.14 times 15, 47.1. Okay, that's much more like it. So 1696 equals 47.1 r squared. And we're going to divide both sides by 47.1. So 1696 divided by 47.1. And we get 36 point something. So we're going to round it to 36. So 36 equals r squared. Then we're going to square root both sides. And we know the square root of 36 is 6. So it's going to be closest to 6. All right, that was weird. It's funny how your brain acts differently when you're not feeling well. Okay, 28. Although I would like to try to, how much time we got left in this period? We got about 6 minutes. I should be able to do one more. All right, I'll try to finish number 28. All right, so Melissa owns a catering company. For lunch and dinner parties, she serves appetizers before each meal. The number of appetizers Melissa serves is directly proportional to the number of guests at the party. For lunch parties, she serves 3 appetizers per guest. For dinner parties, she serves 5 appetizers per guest. When serving 22 guests, what is the difference of the number of appetizers she serves for dinner and lunch? Okay, so we need the two values. So for 22 at lunch, right, it'd be 3 times 22, which is 66. Okay, and for dinner, she serves, 5 per guest, so 5 times 22, which is 110. And it's asking us for the difference, which is subtraction. So we're going to subtract 110 minus 66. And let's go ahead and plug that in. and that equals 44, and that is right here. All right, so we're going to stop there, and I'll try to continue this later today if I have time. I would like to finish this MCAS, this series of MCAS videos. All right, thanks, guys.